ओके थांब लाईव्ह हे होतंय का रन ओके लाईव्ह आहे मी यूट्यूबवर shit I have to speak in English. Okay, I'm live on YouTube and on Twitter. Yes. So hello everyone, this is the first stream of intent acceleration series, and we are going to talk about open intent framework and all the EIPs that come with it. Right now, yes, we can check this. Let me zoom in, and this is the framework I'm talking about. It has multiple EIPs. I just like glossed over it and saw where is it? Yeah. So these things. First things first, we are gonna talk about this. Sorry, the EIP 7683, and then we can move on to these. And I don't know if these are implemented, but our main focus is 7683 because it's in the across docs. Got it. Across protocol ERC-7683. Okay. Also, if you guys can't hear me properly, please do send a message in the chat so I can understand. Yeah. And if there is any lag or anything that you want to tell me, please ping me there. Let me tweet about this that I'm live, and we can go tweet live stream live right now. Let's go through across docs and learn about intents slash ERC 7683. No. And learn how it works. Okay, post Amla. Okay, I don't know how many 3 people are watching on YouTube, on Twitter, no one. So it's a good thing. Anyway, back to our 76831, where okay, yeah, what it is, and we want to talk about this. So in a broad, like I have very high level of understanding for understanding of intents. So when you think about bridges, like what are the two issues that a bridge solves? So we have for bridging tokens from one chain to another, you have two distinct tasks that are going on, which is we want to tell the destination chain that we are transferring assets from source chain to destination, and then we actually have to transfer the assets. So intents help with one of those, which is messaging, that we are telling the contract on destination chain that we want the assets there on the destination chain. and then some filler or relayer will actually go there and fill the intent. That's my understanding. uh, I'm pretty sure it's more nuanced than that, but yeah, that's the gist of it, or what I understand right now. What else? Yeah, so let's go over this. Like, I'm just gonna read it here. I Because this is me learning on stream. It's not I'm teaching you. We are just learning together. So just if you have already read it, just stick with me and we'll go through this. Okay, building borderless Ethereum. Let me zoom in. Yes. Okay. Introduction. We need to end fragmentation before fragmentation ends Ethereum. Okay, that's the part. So layer 2 solutions have achieved their purpose to scale Ethereum network. However, this success brings new challenges: fragmented liquidity and tangled interoperability. These issues are strangling the Ethereum ecosystem, holding it back from its full potential. So, as I talked about, we have two issues where we need assets on both chains because we can't burn like it. If you want to bridge Ethereum, ETH from Ethereum to base, you can't burn it, right? You need to like have ETH. Yeah, you just can't. You can burn it, but it's not economical. Let's say for ERC-20 tokens, you can actually do that, where you can burn ERC on ERC-20 token on source chain and mint on destination chain. That's what USDC does. But for other like assets like Ethereum, that's the issue where like liquidity is fragmented across different chains, uh, and we have to like get it from one chain to different, um, to the destination. Okay, it's time to do something about this. So we teamed up with Uniswap Labs to develop ERC-7683, a universal standard for cross-chain intents. By standardizing how cross-chain intents are expressed, ERC-7683 lays the foundation for seamless and efficient EVM interop. It is key to unlocking truly borderless Ethereum. Okay, so it's like a standard for intents or standard for messages, you can say, uh, or I'll say that because that's what I understand right now. Let's explore. Okay, Ethereum's fragmentation problem. The explosion of layer 2 solutions has significantly improved scalability and reduced the costs across Ethereum ecosystem. However, it simultaneously driven fragmented liquidity and disconnected environments. Simple actions such as transferring assets, executing trades, and participating in governance across chains remains tedious and cumbersome. Users are frustrated by friction filled cross chain interaction, while developers have to manage multiple deployments and inefficient workflows. Okay, a solution is long overdue, but how should we approach this? Okay, they just define the problem where we have like multiple L2s like Arbitrum, Base, Optimism, and n layer of n layer of L2s are there, and we don't have a good solution or good standard to talk with, uh, to communicate with all of those chains. Throughout history of internet, universal standards have driven innovation and connectivity by enabling seamless and secure interactions across networks. The Ethereum community alone has proposed over 500 standards, including, okay, we know ERC 20, we know ERC 721. It's not new. we have seen it, we have used it, everything is there. Okay, so what, yeah, we were here, right? Which sparked the explosion of DeFi and NFTs. Yeah, we know that the key to these standards success was their ability to bridge real gap in user and developer experiences. Okay, now it's time to bridge the cross-chain gap. We need universal standard for unifying Ethereum's multi-chain ecosystem to abstract away cross-chain complexities from user experiences and provide shared foundation for building a cohesive ecosystem by solving the growing fragmentation problem we face today. We can drive record high levels of innovation and adoption. Okay, so they're saying we have to fix the cross chain issue. That was the problem, and that will help us like grow the EVM ecosystem and everything else. Everything else on EVM in the EVM ecosystem. Okay. ERC-7683 cross-chain standard for Ethereum, co-developed by Across and Uniswap Labs. ERC-7683 introduces a universal standard for cross-chain interop based on intents. It aims to simplify and unify interactions across EVM chains, laying the foundation for truly cohesive and interconnected Ethereum ecosystem. Okay. ERC-7683 provides a common framework for developers to build cross-chain experiences that standardizes the expression of intents such as token swaps, NFT transfers, and governance votes across EVM chains. By adopting the standard, developers can build applications that interact seamlessly across EVM chains, providing seamless cross-chain experience for their users. Okay, so my assumption was intents are just for asset transfers, but it's like intent to do any action, and that's what they want to put in the intent. Okay, that's something new. Uh, Let me put a message in. Okay, cool. What else? What else do we have? This the standard facilitates the creation of shared filler networks where participants fillers compete to fulfill cross-chain intents with optimized efficiency and minimal cost. I didn't understand that. The standard facilitates creation of shared filler networks where participants fillers compete to fulfill cross-chain intents with optimized efficiency and minimized costs. Okay, there is layer of like fillers on top of Ethereum that fulfills the intent, or the EVM chains. These unified filler networks handle all the interop under the hood, removing burden from developers and abstracting away the complexities of cross-chain transactions from user experience. Okay, let's see. Cross-chain order. We have this cross-chain order. Sign the order. User funds escrowed in the contract. Initiate order. Filler transfer funds. Repay. Okay, so for first they create the order, then we send that order to the contract, then we send the funds. Next is, but how, I don't understand like how this contract interacts with this, and these fillers like send the guarantees. Are there, how, what are the trust like assumptions? I don't know. That's you. Okay, maybe that's what it is called, trust assumptions or something like that, where we want to uh, this contract, like how does it verifies, that's what we need to understand. uh, how it verifies that filler has transferred the funds. Is it like Oracle or ZK proofs? What is that under the hood? Okay, key benefits of maybe this. Okay, this then it doesn't actually explains it. We have key benefits. Okay, let's read it. Unified filler networks, builders can leverage shared filler networks to fulfill their users' cross-chain intents in a robust and secure manner. The setup creates a win-win. Filler benefits from flexibility, cost savings, and access more order flow, while applications can route user intents to broader and more competitive network. Ultimately, user experience fa- faster fills and lower costs thanks to increased capital efficiency fillers bring in the process. Okay, so there is a network of fillers on top of all the EVMs, where they compete with each other. um, it's similar it's similar to like build, what was that, flashbots, or something like that, where uh, the blog the researchers compete for different orders to be bundled together and like extract a maybe. But here maybe not. It's it's not exactly the same way, but let's see. It depends on how these intents are executed, like who gets to fill the intent, and how that person is how that filler is chosen. That's the important part, because if anyone can compete, then there is a chance that they might extract some value out of this, not just fees, like more than that. Enhanced user experiences. ERC-7683 enables apps to abstract away cross-chain complexities from their user experiences. All the interop executions happen under the hood, freezing users to simply focus on their intents and enjoy faster, cheaper, simple cross-chain transactions. Okay. Developer efficiency. It standardizes. Okay. Uh, ERC 7683's standardization reduces development costs and speeds up integration processes. Filler networks undertake the burden of fulfilling cross-chain transactions, making it easier for developers to implement cross-chain features into their apps. They no longer have to worry about handling interoperability themselves. Okay, I don't know how that will work unless we actually have to see this. See, we actually have to see the example where they have implemented this, and what do they mean by like developers no longer have to worry about handling interoperability themselves. I don't know. There needs to be a function that verifies uh, particular messenger sent this, and it's true. So not sure what this is unless I see the demo. Flexible settlements. The standard is agnostic to settlement verification. Where is this? Okay, I'm here somewhere. The standard is agnostic to settlement / verification systems, enabling iteration and experimentation that will benefit dApps and users. Projects have the freedom to choose verification methods that fit their needs, encouraging diverse approaches and a resilient ecosystem. Not sure what this means, but let's see. Filler accessibility. The standard reduces costs and lowers the entry barrier for fillers, encouraging broader participation. Reinforces less this reinforces less reliance on centralized fillers, creating a more decentralized, inclusive, resilient filler ecosystem. Okay, so multiple people can participate and be filler and go into that filler network. Chain agnostic. Since since the standard operates at application level, no changes are required from individual chains to ensure compatibility. Okay, that's great. I'm not going to read this because that's not useful. Uh, that's not useful in a like developer sense. It's telling what we can use it for. We already know. Okay, the supporting support for the support for ERC-7683 is growing fast. Okay, the campaign is catching massive momentum across CVM, attracting some of the biggest ecosystem projects across the entire Ethereum landscape. Below are the projects that are committed to unifying the Ethereum standard. Okay, I understand these. I don't understand why Celestia is there. Like Celestia is not in the ecosystem. It's not in the EVM ecosystem. It's different. Movement. I don't. Okay, maybe Movement has EVM. That I know. Okay, maybe they have some idea that I don't understand right now. Conclusion. What's It's more than just standard. Truly unified interop. Okay, by connecting chains, create more user-friendly environment. Okay. Okay, contact us. No, not right now. Let's read this and FAQs. What is a cross-chain intent? Cross-chain intent represents, yeah, as I said, like it's a action. It can be anything. Before that, I was saying, I thought it was just like asset transfers and not like anything else. But you can send maybe a call data or something like that. Who knows? We have to see. What is the standard? Users. Okay, relayers. I think relayers. What they said. The article said it was fillers, right? Fillers and relayers. I think they are the same things. Compatibility question. Yeah, that's a relevant question. These two standards are different. This is like a wallet standard, and this is we can make it compatible or complementary. Okay, I was just reading this. We are gonna go over this and see what it is. Right now, let's focus on 7683 introduction. Also, we can go to EIP also in the. Okay, this is the EIP. Let's go through intro and then it's a intent standard that we know. Fragmentation, intent. Okay, it just tells what we talked in the what we talked in the blog. Same thing. Intent. What is intent? Everything else we know that already. Reach out. Okay, let's go to specification. An interface for cross-chain trade execution systems. Okay, we already know this. It was proposed by Uniswap and Across. Okay, with the proposal for the new standard, Uniswap and Across has jointly published an ERC to the forum. Okay, let's open the forum and see what people are talking about. Okay, caution intense. This is important space to solve on. Settlement swaps, etc. Okay, let me take a break. I was thirsty, so I just drank some water. Anyway, few technical questions. Settlement, swaps, etc. seems assuming a specific token or token standard and a clearing slash settling environment. Have we thought about making it something more general like user op? On other hand, assuming this standard just wants solve cross-chain token settlement, and how does resolved cross-chain order includes attestants from settlement chains? Okay, this is the one. Now we should go through this first. We know what it is. Let's go to the author's GitHub and see where they work at. It's Uniswap. Uma is like the, I think it's parent company, or Uma, Risk Lab, and Across. It's like the same team. So I don't know the exact relation, but it's, yeah. What's next? It's same, Uma. Okay. What blogs has they written? Oh, I don't know. Announcing where do bridges leak MEV. Yeah, and this will be interesting read at least, but it's 2 year old, so maybe things have changed, and definitely Across has changed things, so we don't have to It's just for learning. It's not for. I don't think it's practical right now. Its name is changing. Okay. Okay. Is it April 11th or 4th November? Magician. Okay. April 11th, I guess. Abstract. Following standard allows the implementation of standard API for cross-chain value transfer systems. This standard provides generic order structure as well as a standard set of settlement smart contract interfaces. Okay. Motivation. Intent-based systems have become a permanent solution for end user cross chain interaction by abstracting away the complexity and time constraint of traditional bridges. Okay. One of the key difficulty for cross-chain intent system is accessing sufficient liquidity and network of active fillers across chain. This challenge may be exacerbated as the number of distinct chains increase over time. The end result of this is a poor experience for users, including higher gas cost, long wait times, and higher failure rates than necessary. By implementing cross-chain intent systems, by implementing a standard cross-chain intent system can be in interoperate and share infrastructure such as order disman this I don't know uh, dissemination service and pillar networks, thereby improving end user experience by increasing competition for fulfilling user intent. Okay. Terms. Destination chain, the chain where intent is executed and user receives fund. Yeah. Filler, a participant who fulfills user intent on destination chain and receives payment as a reward. Yeah. Like a portion of user intent that can be executed independently from other. All legs must be executed for an intent to be considered fulfilled. Okay. So if there are multiple things, multiple actions, leg is one of those actions. That's what I understand. Okay. Next, origin chain. Okay. It's the chain that user is using right now. Settlement system, a system that custodies user deposits, verifies fields, and pays filler for purpose of facilitating intents. A settler, contract that implements part of settlement system on particular chain. User, for purposes of this document, the user is the end user who is sending the order or creating the intent, as you say. Okay, what else we have? Order structure. So a compliant cross-chain order type must be API decodable into either gasless cross-chain order or on-chain cross-chain order type. Okay, we can go through this. notice standard order struct to be signed by user dismant okay to filler and submitted to original origin settler contract by fillers. Okay, disseminated address. Filler sends this order to fillers. Okay, this contract, the contract address that the order is meant to be settled by. Filler sends this order to this contract address on origin chain. Okay, so this is the settler contract whose input tokens will be taken and escrowed. So this is the end user. Nonce, okay, replay. It's similar to any transaction in EVM. We are like preventing the replay attack, and that's why the nonce is used. Chain where chain ID of origin chain, timestamp by which order must be opened. Okay. Okay, the timestamp by which the order must be fulfilled on destination chain. Type identifier for the order data. This is ERC-7783 type hash. Okay, and I understand that. If you don't, like, please go and look at EIP 712. You'll understand. It's not that difficult. And this is just everything else. Implementation specific data can be used to define tokens amounts, destination chains, fees. Oh, we can also, if it's saying like destination chains, it's multiple chains. So we can create an intent and fillers can fill those intents on multiple chains. I guess that's possible. Probably a single filler has to do everything, but I'm not sure. We'll learn that throughout like next few weeks what it is. On chain cross chain order. I don't know what difference between these two are. Standard order structure for user opened order where where the user is only submitting, where the user is the one submitting order creation transaction. Okay, so this is like you are signing with your MetaMask and this is someone else is doing that. Timestamp can be defined, same thing. Order type, last three things, these are not there. Yeah, this is just message, right? This will be message and this will be actual transaction, so there is no need for nonce or anything like that. Cross-chain execution systems implementing this standard should use subtype that can be passed from the arbitrary order data field. Okay, any contract that is executing the intent should know how to pass the order data. That's what they're saying. This may include information such as tokens involved in the transfer, the destination chain IDs, fulfillment constraints, or settlement oracles. Okay, so for settlement they are using Oracle. that was one of the question, right? Like how they are confirming intent is fulfilled on destination chain from origin chain. So there is some kind of oracle. I don't know what I don't know if across uses the 7683 right now, and if it uses it, how the settlement works. That's what we want to learn. Resolved cross-chain order struct. A compliant cross-chain order must be convertible into the struct. This means that order data must be decoded into information needed to populate resolved cross-chain order struct. Additionally, order data should be decodable into subtypes which can be used for further functionalities such as cross-chain call data execution. See the examples section for the example of this. Okay, there are examples. We can learn from them. It is the responsibility of user and fillers to ensure that the original settler supports their orders contain subtypes. Fillers and users and fillers. Okay, settler contracts needs to know how to pass this. Otherwise, it doesn't understand how to settle it. Okay, pretty clear. User deadline output that fillers will send. It's possible output minimum tokens amount chain fulfill instruction does the max. I understand rest of this. That's pretty straightforward. These are the things that are new. So let's go over them one by one. The max outputs that the filler will send is possible to actually it's possible the actual amount depends on the state of the destination chain. Destination Dutch auction, for instance. So these outputs should be considered a cap on filler liabilities. Didn't understand a word out of it, like even a single word of it. Let's move on. As we go forward, I'll start to understand. So as we go through examples and rest of the things. Okay, let me just check YouTube, Twitter. Okay, there are 3 people watching on YouTube and 19 on Twitter. So thanks, Twitter. But you guys can send me a message in chat or something like that. Would love to see how many guys are there. Guys, gals, like everyone. Just want to know. Yeah, okay. Let's go to minimum received field. Minimum output that must be given to the filler as part of order settlement, similar to max spent. It's possible that special order types may not be able to guarantee the exact amount at open time, so this should be considered floor on filler receipts. Setting the recipients of an output to 0 indicates that filler is not known when creating this order. Okay, didn't understand last part, but first is like how much minimum amount of token you can accept. That's what they are trying to ask, I guess. Yeah. uh, each instruction in this array is parameterized a single leg of the fill. This provides the filler with information necessary to perform the fill on destination chain. Destinations, okay. As I said, if yo Aditya is hey, hi Aditya, thanks for joining the stream, man. uh, yeah, as I was saying, the intent can be any action, right? So we can perform multiple actions on multiple chains, and each action is called leg, and that's what they're saying. Like fill instruction is that's uh, that's that. Fill instruction will have these things. So origin data will be may something like call data, right? And output is the token recipient and where they want to receive. We have read this here, these two things. Okay, open intent. A compliant open event must adhere to following ABI. Order ID. We haven't seen like how order ID is created. Like, are they hashing the what was this? Yeah, resolved cross-chain order struct. Are they hashing this and how they are creating it? That's we don't know that yet. Settlement interfaces compliant. Okay, let's see this one. Settlement interfaces a compliant origins settler contract implementation must implement iOrigin settler interface. Okay, so these functions should be there. We'll go through a demo. Like they should have a demo, right? Examples are there. Is there a GitHub or something? ERC-7683 GitHub. I want to see that. Okay, I want the settler contract and rest of the things. Here they are showing some demo, but it's not. This is not what I'm looking for. So let's keep looking. Hyperline basics. 7683. Yeah, we just saw this, right? Base. What are they? What are they doing? Okay, yeah, I was looking for this. So order ID. Yeah, you see, order data type and order data. When we like encode it, it will give bytes 32, and that's the order ID. We are setting it to open. Oh no. Sorry. Resolve order. No, I don't want that. Oh, I guess we have to implement it and generate the ID. So you see, yeah, I guess you understood like what I wanted to say. We have to implement this, and that returns the order ID nuns and this struct, whatever this is. Okay, so we can create it. Let's just keep this. You can check the Notion that I have linked on YouTube, where I'll take notes and everything will be there. This URL will be there too. So just keep that in mind. Okay. Compliant destination settlement contract must implement our destination settler. Okay, understood. We saw this interface, right? I origin settler. Did we see this one? Do we have fill function fill? Yeah, we have that too. So this contract implements all of those things together. Okay, filler data. Yeah, filler data. Cross-chain execution systems implementing this standard should use a subtype that can be passed from the arbitrary filler data field. Okay, this may include information such as desired timing or form of payments for the filler. Okay, basically it's an arbitrary data and we need to be able to pass it. That's the gist of it. All subtypes, and we'll know the details when we see the actual demo, not in this. All subtypes should be registered in a subtypes repository to to encourage sharing of subtypes based on their functionality. Okay, isn't there better way to go about it? uh, Sharing subtypes is great, but is there like good way? uh, just putting them in like a repository, it's not. I don't think it is. Like, can we have something on chain? Who knows? Rational. Rational. Okay, it's pretty hard to understand because yeah, the rationale, like if you want to read it, you can. I'm not gonna because it's way too complicated to understand, and they are just telling why they have done it. And I'm not really interested in that part. I'm more interested in like understanding the implementation, not the reasoning behind it. What's next? I wanted to check examples. Yeah, this is an example. Okay, can we go in this? Yes. Oh, it's a like full on example. That's a to illustrate. If you want, you can see the example in the EIP, but I'm gonna check the example on the site. Okay, to illustrate the flexibility of the standard, here are some more examples of how resolved cross-chain order could be defined. Uh, Across plus permit to example. Okay, permit to is, I guess it's they're just creating it, right? No, Permit to it's token thing, right? uh, Token approvals and that. Yeah, I got confused. Yeah, permit to is approval. What I was thinking about, generate create contract with predefined address. Okay, oh, create to, sorry, I was thinking of create to, not permit to. Okay. Cross-chain order on across has a single input and output token, and filler do not get full amount, full input amount refunded. Instead, a cross contract on origin chain ID would define a function like get filler fees order repayment chain ID to deterministically compute the fee charged to them. Filler on across can choose where they want to receive their funds, uh, where they want to receive their refunds. Okay. um, sure, and somewhat understood. This is this exam this example settlement contract contains a fill cross-chain order in the settlement contract that fillers can use to fulfill initiated orders, which uh, sorry, fills for other settlement systems might be submitted to different contracts than the settlements contract itself. Okay, they have some state variables, and this is cross-chain order. Exclusivity, exclusivity deadline, exclusive relayer, message, struct, repayment chain ID, initiate order. Okay, we have order, permit to, resolve order, swapper. Okay, it's an event. This is processing the permit to signature. Resolve is here. We want to see this underscore resolve function. That's more, that's what's interesting. It returns these three structs. We are decoding order data. It's a random data, right? So we have to decode it. We know the structure. We get order data. We are okay. Filler data. Output fee computation. Copy F. Okay. It might be somewhere. Resolved cross-chain order. No, I still don't understand. Like it's creating something on chain, on origin chain. It's not the thing that happens on thing that happens after the intent is filled on destination chain. It's just they're telling like what to do. Okay, that's good, I guess. I was looking for something else. Okay. For now, we are good. Uh, I'm gonna end the stream, but Yeah, uh, we understood like basics of what intents are. Then we went through what the standard is. Just like we didn't actually understood the whole thing, but we actually did go through the standard and read most of it. Now tomorrow we are gonna see the actual across docs and are they using 7683 for their current implementation, and how settlement works after the intent is filled on destination chain. Um, yeah, that's a plan. So tomorrow we are gonna spend most of the time in the across docs learning about the system, and if we get a chance, we will also go through the contract implementation for for the intent. So we have I settler, right? And then there was another one. So how across implements it, that's what we want to do. Okay. Thanks for joining today's stream. Hopefully you liked it. If not, let me know um, what you. Okay. In any case, let me know what you liked, what you didn't like, on Twitter, in DMs, in chat, anywhere you want. And yeah, thanks for joining. See you guys tomorrow, same time, and have a nice day. Bye.